Hello everyone. Today we are going to discuss about the crystallography, and this is our first take on the introduction to crystallography. Now the question is, what is crystallography? Crystallography is the study about crystalline solids and the principles or the laws that govern their growth, external shape and the internal structures are called crystallography. A crystal is a solid that possesses the internal ordered arrangement that is characteristic of a crystalline solid. When conditions are favorable, they may be bounded by smooth plane surfaces and assume regular geometric forms known as crystals. Today, most scientists use the term crystals to describe any solid with an ordered internal structures regardless of whether it possesses external faces. To define a crystal in three dimensions, we need three imaginary axes, and they are termed as A axis, B axis and C axis. These three are crystallographic axes. A and B are horizontal axis and C is up and down in position. That is, A and B are horizontal where A is front and back in position, B is left and right in position and C is up and down in position. The frontal end of A axis is denoted as positive end and the backward end is denoted as negative. Right side of the B axis is positive and the left end is negative. Upper part of the C axis is positive and the lower end of C axis is denoted as negative. The angle between the positive ends of these three axes can be termed as alpha angle, beta angle and gamma angle. Here alpha is the angle between crystallographic axis B and C. Beta is the angle between crystallographic axis A and C, and gamma is the angle between A and B. Based on the length of crystallographic axis and the value of alpha, beta, gamma, we can classify the crystal into 6 different classes. Number 1, triclinic system. Number 2, monoclinic system. Number 3, orthorhombic system. Number 4, tetragonal. Number 5, hexagonal system. Number 6, isometric system. In case of triclinic system, length of A axis not equals to length of B, not equals to length of C axis, and alpha angle not equals to beta, not equals to gamma, not equals to 90 degree. In case of monoclinic system, length of A axis is not equals to B, not equals to C, and again alpha equals to gamma but not equals to beta, and this beta is also not equals to 90 degree. In orthorhombic system, length of A axis not equals to B axis, not equals to C axis. That is, these three axes are unequal in length, and alpha equals to beta equals to gamma equals to 90 degree. That is, A, B and C axes are mutually perpendicular. In case of tetragonal system, length of A axis equals to B axis, that is, the two horizontal axes are equal in length, but these two horizontal axes is not equals to the vertical axis C, and here angle alpha equals to beta equals to gamma equals to 90 degree. That is, A, B, C axes are mutually perpendicular. Next is the hexagonal system. Here there are three horizontal axes and they are named as A1, A2, A3, and these three are equal in length, and the vertical axis is C. All the horizontal axis makes a 120-degree angle, that is A1 angle A2 equals to A2 angle A3 equals to A3 angle A1 equals to 120 degree, and C axis here mutually perpendicular to all the horizontal axis, and hence C angle A1 equals to C angle A2 equals to C angle A3 equals to 90 degree. Next is the isometric system. In this case, all the axes are mutually perpendicular, therefore alpha equals to beta equals to gamma, and all the axes are equal in length, that is A equals to B equals to C.